Yeah, I was not speaking anything. I was just setting my screen and all. Okay, so let's get started. I think we were discussing NumPy in the last class. We have to quickly move along. I mean, initially we spent a few sessions to try to get some hold of Python. But now I think some of you are getting slightly used to the tool. So slowly we have to move forward. Possibly at least in this week or the early next week, we have to get started off with the concepts of data science, which is the machine learning and things like that. So yeah, so with that, just a quick overview of Python, NumPy, numerical Python, multi-dimensional array object, collection of routines for processing. So everything in a NumPy, everything is about array. Just like the way we talked about lists, tuples, dictionaries, and sets in the base Python, NumPy has introduced one additional data structure called array, which is otherwise basically called ND array, which is the n-dimensional array. And we can perform a good number of mathematical and logical operations on the array. So generally what happens is, right, it's an n-dimensional array, collection of items of the same type. So to a large extent, everything is numerical in NumPy. That is possibly you can call it as a limitation. To a large extent, it's a numerical related calculation. So that is why it is called NumPy. And it has a zero-based index, which means the first element of the array is having an index of 0, then following 1, 2, 3, just like in your base Python. And every item in an array takes the same size of the block in the memory. So if you are talking about a two-dimensional array, then we will talk about n number of rows and n number of columns of that particular array, m number of rows and n number of columns. So the memory usage is more or less the same, which means even if you are giving it as an integer, it will typically store it as a float. And generally in a computer science terminology, the integer occupies lesser memory space, whereas the float occupies a higher memory space. And so you can extract subsetting, slicing, all those things that you have done in regular Python, in the base Python, you will do the same thing in NumPy as well. Is it still not audible? Nabeen Sen? Am I still not audible? Okay. I think then it must be an older message. So because it's a library, you have to import that library. And anything that you want to, generally what we say is we import, we do not import NumPy as it is. We give an alias and try to import it, right? So we can very well import that NumPy. So when you are saying numpy.array, we get a data type of numpy.array. Now, how do I create arrays in Python? So for that, either I can use a list or a tuple, the basic base Python's list or tuple, and I can convert that into an array by using the numpy.array. Or generally, we use an alias for NumPy. We say import NumPy as NP. So then we say np.array and we put a list inside it. So if you look at it here, we have imported NumPy as NP. Now we create a one-dimensional list, 10, 20, 30. Similarly, you can create a tuple as well. Tuple is nothing but you put a normal bracket. Then it becomes a tuple. You put a square bracket, it becomes a list. You put a flower bracket, it becomes a set. So you simply say np.array and give my list. So it becomes an array now. Now it's no more a list. Now it becomes an array, right? So what happens? Why we need to understand all these data types is there are so many ready-made functions which take a specific data type as input, a specific data structure as input, and give an output. Possibly, if I want to do a logarithmic calculation, I may be having one function from math, one function from NumPy. All of them are calculating the logarithm only. But the function that is available from NumPy actually does a much faster calculation compared to the function from the base Python. But what happens? This requires the data to be either in an array format or some format that can be converted into an array format, right? So that is where possibly we need to understand the data type. Even if you have a two-dimensional array, so two-dimensional list, which is like list of lists. So you have created one list where there are three lists inside. So one list is having three elements, the other list has three elements, the other list has three. So you can very well create an NP array of these lists also. Okay, I did not define, sorry. So most of the time, the common packages are imported by using some kind of alias, because we will be using many functions from that particular package. So if we are using, rather than typing out numpy dot, numpy dot, numpy dot every time, you can very well use np dot. Now you can very well look at the type. So type gives, earlier used to give a list, then so it used to give list or tuple or something. Now it is giving numpy dot nd array. So nd array is basically an array. So n-dimensional array. So you look at the shape of the array. So shape is giving you the dimension of the array. And the dimension is given in the form of a tuple. Right? So n rows and m columns, it will give you this comma this. Length of the shape is therefore the rank. Whatever is the length of the shape is the rank or the dimension, number of dimension. So if I can create a three-dimensional array, four-dimensional array also. That is where arrays become more comfortable, especially if I have to work in higher dimensions. Typically in image processing and all, I may have to work in higher dimension. So one dimension I'll use for R, one dimension for green, and one dimension for blue, RGB, and possibly the picture itself, right? I can very well think of the picture itself, the length, the width, and so with all these things, possibly under number of pictures. So basically I can have the picture ID as one dimension, then possibly the length of the picture as one dimension, the width of the picture as another dimension. So I can very well represent all these things in different arrays and make it as a three-dimensional array, four-dimensional array. So sometimes in those cases, compared to using any other library, the Python's NumPy library would be more useful to work around with. D type is a function that will give you the data type. We have already seen that. So type of will give for the overall thing, whereas the D type will give you whether something is a Boolean value or an integer value or a float value. So you can very well see here, integer, 32-bit integer, 16-bit integer, and floating. Floating is like 64-bit. So it's a memory that it is occupying. So NumPy integer 16 is more like it occupies 2 bytes of memory, 4 bytes of memory, and 8 bytes of memory. So obviously when you are dealing with small data, it does not matter much. But when you are dealing with large size data, the storage will always make a very important consequence, right? So D type, as we said, it could be Boolean, integer. Integers could be integer 16-bit integer, 32, depending on how big a number that you are trying to store. Normally, it is like any number between minus 2000 2 to the power of 15 to plus 2 to the power of 15. It can be stored as a 16-bit integer and so on. Floating, if it has the decimal points and all, if they are there in the data, then it can be taken as floating. Okay, then string is mostly a string which would occupy a larger memory. So you can simply convert this into a list. Sorry, convert this list into an array. You can find out the D type of the array because they are all integers, and if you don't specify a specific integer, it takes the 64-bit. Then you can also print the shape of the array. Shape is nothing but, so how many dimensions, what is the number of, n by m. So number of rows and number of columns. So if it is just a one single dimensional kind of an array, it just gives the one single row, 3 columns is the typical array. So if you want, you can print this array. You see, when you are printing this array, so it is having a the shape has to give n rows and m columns. 1 row, 3 columns is this. Okay, let us see possibly when I look at the 2-dimensional array here. So here it is showing 3 rows and 3 columns. I think if it is having only 1 row of data, it would show 3 elements in the row, and basically it's a single column. So it's a columnar. It's a row array. So row arrays are represented primarily like this. Yeah. So it is. It has to be 1, 3. I think this is the representation. It does. We'll explore it. I mean, I have not given too much of importance to this, but definitely I will see. So if it is there is some difference when it is a row array versus a column array, right? So I think there is some small, especially the row array and a single row array, single column array are treated slightly differently. So I'll just get back to you. I'll make a note of this. What is that special rule? And I'll come back to you. So column 3. So there are 3 columns, but yeah, the way it mentions, I think there is some small difference. I'll come back to you on this. Then, so here, the main object is the ND array itself. So you can look at it as a table. Possibly you can think of it as table, but they are typically, but here the only thing is you can't define the row names and the column names. Though it's a table, you can't define the column names. You have to access it only by the location. Possibly you can call that as a disadvantage, but because of a lot of other operational flexibilities, that could be an advantage as well. So the dimensions are simply called access. You don't have labels to each of the dimensions. So in a table, you can keep the names of the tables, column headings. Whereas here you can't do that. because it is mostly like only numerical. So array, possibly something like a matrix. So everything is treated as just one array. So the array, depending on what dimension it is called, that is the rank of that array. So if it is a two-dimensional array, we also call the rank of that array is 2. And in the first dimension, we are having whatever are the number of elements that are there in each row. So row wise, we have 6 elements. Oh, sorry, correct. So what are the number of elements in the row? Not the number of rows and number of columns. Yeah, this is right. So I got slightly. So it's a number of elements that are there in the row, comma number of elements that are there in the column. So there are 3 elements in the row here. And in the column, there is 1. But if there is only 1, it would not be specified because it will typically say that it's so it is actually called as a row array. Row array, generally the column values are not specified. And if it is a column array, generally the rows are not specified. So here we are having 2 rows. So if you are looking at the shape, there are 2 rows and there are 6 columns. If it is a uni row or a uni column, so it typically represents in a slightly different manner. So if you are looking at for a multi-dimensional array, the shape gives very much clear how many rows are there and how many columns are there. So for a uni row and uni column, I think we have something different, but because we generally don't use much of that uni rows and uni columns. Generally, for those things, when you work with the tables and all, you generally access them using the pandas. So you don't use single rows and all in NumPy heavily, and that's where somewhere I have to check on that rule. Okay. So now we have a few built-in methods. One is, so we have already talked about the range when we talked about the base Python. So on a similar note, we have something called a range. A range is a kind of a NumPy function. So the same thing, start, stop, step, and whatever is the time. So basically, you can very well say, I want to go from a range from 0 to 10. Then it will print 0, 1, 2, 3. So basically, the 0 will be included and 10 will not be included. So 0 to 9 will be printed. And there are some interesting functions here. If you want to generate all zeros, because for some matrix operations and all, you may really want to generate something like this, whether for matrix operations or for some kind of rule based. So if you want to loop something, initially you may want to initiate all the values with zeros, and after that you may want to update them with some function values. So as we move along, we'll be knowing, but right now you can simply think of, if you want to insert 2 rows and 3 columns, everything with zeros, you can do this. Or if you want to put ones across, so possibly some kind of see, generally when we are working with let's say solving a linear equation or something, we may want to initially start off with ones for all the variables, and after that do some kind of optimization of the values. So in those kind of cases, you can very well update with one single value 1. So basically we have functions called np.zeros, np.ones, and you have one more important thing called I. I is like an identity matrix. So you can create one kind of identity matrix where the diagonals are 1 and all the off diagonals are 0. Then sometimes we would be interested in creating evenly spaced numbers over a particular interval. So we start from some number, stop at some number, and we create 50 uniformly spaced values. A number of uniformly spaced values. Then we can even go with that. Like this, you want to go from 0 to 10 with 7 intervals. So obviously the gap. So basically this one, if you want to, as a part of your interpolation problems, etc., this could, I mean, you want to put, you want to take 5 points between two sets of points, and for each of the points, find the value of y. So possibly as a part of numerical methods, or if you want to, right, you want to solve a function for all the intermediate values of x, you take a kind of a linear interval between a and b, and you try to fit the values, right? So that is one more application that you can think of. Then the next, okay, let me see if there are questions. Number of elements in A is 6. Yeah, as I told you, if it is a two-dimensional array, it would be typically treated as number of rows and number of columns. But if it is a one-dimensional array, it will simply talk about the number of elements in that. So I'll just update you on that slightly later on. I mean, I can Google it now, but I think I'll update it slightly later. But it is not such a critical thing. You can also Google it out and try to see that. I could not understand this code. Which code? The linspace. See, linspace is nothing but, let's say, I'll just write it out. So I have a minimum value of something, 1, maximum value of 20, fit 5 different points between them. So the minimum value should be 1, maximum value should be 20, and I want to fit 5 different points in between, right, which are equally spaced, right? I want to split, so possibly, so the gap between the two is 19 divided by 5. So possibly it's like for 3.8 is the gap. So 1, 4.8, then 3.8 is 8.6, then another 3.8 is 12.4. Then another 3.8 is 19 point, sorry, whatever it is, 16.2. Then it is 20. So basically we are trying to, so sometimes if I want equal gaps for various reasons, so this is one more function that can help me do that. Okay. Then many a times, possibly in statistical analysis, in simulations, etc., we work a lot with random numbers. Possibly if you want to generate data from a distribution, right? A lot of applications are there where we work with random numbers. So we can use NumPy functions for generating the random numbers also. So rand, if you are just using np.random, right, numpy.random or np.random, np.random contains different kinds of random numbers. So you can use simple rand. It will actually give a uniform distribution, values that are uniform, random values that are following a uniform distribution. You can give the range. So between those two values, it will give you a set of values that are following a uniform distribution. So as you all know, uniform distribution typically has, every distribution has some set of properties. So you can say uniform distribution between A and B. So it will randomly pick up some value between A and B and it will give. So the uniform distribution typically has a mean value of A plus B by 2. Right, and possibly you can talk about the variance as b minus a whole squared by 12. Now, going by those things, following that typical rule, some values will be generated for us. So that is what is the rand function. Now we have a rand n function which is actually generating normally distributed value. So just like the uniform distribution, the rand n will actually give me the randomly distributed value. And if you are using rand int, then it will only give me integer values between the two ranges. So it will give me only the integer values. Let's try out. So you can simply say rand 3, 4. Then it gives uniform distribution. So 3 rows, 4 columns. So it will say, so when I'm saying 3, 4, it will give me 3 rows, 4 columns, all the values lying between 0 and 1. Now you could give something else. np.rand random.rand. So possibly you can look at the help. So it typically gives you random values in a given shape. So that's the only thing that it can do. So you can look at the help on this function. So you can give only the dimension, and it always generates the value populated with the random samples from a uniform distribution over the 0 to 1 range only. 0 will be included, 1 will not be included. So that is what is this function doing. Now if you say, what if I want to generate a random number between 3 and 4? So first you generate between 0 and 1, and possibly you do some kind of multiplications and additions to generate it in some other range. So possibly here, if I am saying 3, 4, you see 3 rows and 4 columns, some values between 0 to 1 are generated. So that is what is this rand. And you could see here again the same thing. So you can rand n. So it is following a kind of a normal distribution, right? You can very well generate the values which are following a normal distribution. Probably you can typically check out here. So this is a kind of a built-in method again. So it will generate the random numbers in a 2 by 3 array, and a standard normal distribution is what it typically takes. Standard normal distribution is that particular distribution which has a mean of 0 and a standard deviation of 1. And okay, now this is where if you want integers to be generated randomly, you can very well give the rand int function. So you say random int between 4 to 40. You typically generate between 4 to 40, generate 10 different integers. So if you look at this function has that additional this thing. So you can very well generate the number of integers. So randomly you can generate 10 different integers. So basically you are seeing that 17, 18, some numbers are generated. Up to 50, so you can use the rand int and you can give the size. This is also a different way of specifying the same. You can very well specify the number and you can use the function called size. So you can use the parameter called size, and which can give you the random numbers in a particular order. Now, so this is random. We will see basically here, my objective is to quickly tell you that these are so many things that that NumPy can give, pandas can give, right? But our intention is primarily, if I take up a data set and start working on solving some problem, then what are all the things that come into my way? So I think we should move forward to that level, because most of the times we would be given some kind of data sets and we would be asked to do some kind of analysis on those data sets. So we should get that basic comfort to work on the analysis on the data sets. So possibly we will move slightly forward to go to that level. Now, operations wise with the NP arrays, right? So you could, so if you are actually working, this is another important point in Python in general, and NumPy also in specific particular. So any operation with a scalar number or scalar function will cause the operation. This is actually a very, let's say you add 2 to a particular array. So basically we'll take this array, right? I'll call this array as temp. Just to give you a comfort, I'll call this array as temp, print temp. Then I'll say temp1 is equal to temp plus 2. Then I say print temp1. You could see here the temp is some numbers. This is a random number. So it is printing this. But after that I said simply add it to. Then it will add to all the elements. So any scalar that you add, subtract, multiply, divide, any single number that you add, subtract, multiply or divide, it would be applicable to all the elements of the array. So that is one important point. Any operation with a scalar number or a scalar function. So you say square root. So you can very well say temp2 equal to np dot square root of temp. Right? When you are saying this, np dot square root of temp, and probably you say print temp2. Then you see for all the values, right? So square root of 19 is 4.35. So it will print all the, so basically any function, any scalar function that you are applying. So you can think of it like a matrix. But in matrix, sometimes when you do a matrix addition, if you just normally if you simply add a 2, it does not add. In matrix, everything has to be a like. In matrix, everything has to be a, like-sized matrix should be there. So if I'm adding one matrix to the other matrix, then both of them should have the same number of rows and columns. Otherwise, the matrix addition will not be possible. But here, what happens is the concept is still the same, but internally what happens is the size of that single would be equated to that of the other one. So that is where you could see that a single array can very well be added. Any operation with 2 compatible arrays will cause 1-to-1 element. So basically, if you have added these 2 arrays, then they will get simply added up. So 19 will be added to 21, 32 will be added to 34, and so on. Because they are 2 compatible arrays. So if you have added as a single element, then that single element will get converted into a compatible array. Whereas if you add 2 compatible arrays, they would simply do an element by element kind of an addition. So all elements between arrays are element wise, right? So when you are multiplying 2D vectors, this is one more. If you are multiplying 2 arrays, it is not that it will do a matrix multiplication. We have to be very clear. It is simply doing an element by element kind of a multiplication. So possibly if I do this, you look at this is somewhere I think people sometimes make a mistake as well. So if I say temp multiplied by temp1, so this is 19 times 21, 32 times 34, 6 times 8, 2 times 4. So it's a element by element multiplication. Okay, so for matrix multiplication, we have a different function. We'll come to that. But typically, we have to understand when you are simply doing a multiplication, because they are looking like matrices, it does not do a matrix multiplication. And for scalars, I have already discussed. So you can simply look at some of these things here, quick, even a division example. So I have created an array 1 which starts from 1, goes to 10, 10 not included, and it's a range, it's not a random. So it takes values, and these are all floating numbers. The data type, we are giving it as a floating number, and we are reshaping it. Now here what has happened, I am getting the values 1 to 9. I am reshaping it as 3 by 3 matrix. What is this reshaping doing? The same 1 to 9, it will arrange it as a 3 by 3 kind of an array. Similarly, array 2, we are taking the values from 100 to 109, floating numbers, reshaped. So if you want integers, you can very well say into 16, into 32, or into 64. This is also reshaped as, so it will take numbers from 100 to 108, 109 will not be included. So you are printing these two arrays. Then I am dividing one array by the other, just like the way I said, if I have two compatible sizes, right? So this is a 3 by 3, this is a 3 by 3. So if the two are having compatible sizes, it will simply take the element by element, 100 divided by 1, 101 divided by 2, 102 divided by 3, and so on. But if it is like you are dividing it by a scalar, then the same divisor will be used for all the observations. So this is the division element of it. Then sometimes I can even give comparisons. Comparisons, logical operations, etc. also work in the same way. So probably you could typically say, I generate some kind of randomly, normally distributed random numbers, a 2 by 3, a 2 by 3 matrix of randomly distributed, normally distributed random number. Now, basically, this will generate, right? Possibly, let me print this also so that you will get how it is printing. You can very well generate, right? So I'm printing these temperatures. Then I'm defining one variable called greater than 0. So wherever the temperature is greater than 0, it will say true. Otherwise, so because we are talking about logical operators, the logical operators will return true or false. So we are saying print temperatures. Oh, these are already printed. Sorry. So we say print temperatures and print greater than 0. So if I can also look at the type of, so basically this is what you have to keep looking at, right? The types, because that is what will help us if there is some incompatibility. So you could see here, the first thing we have printed is temperature. These are the values. And we said greater than 0 is temperature is greater than 0. So whichever are ones are the greater than 0. So this one is greater than 0 and this one is greater than 0. So it is saying true, but all the other 4 it is saying false. Type of greater than 0 is ND array, because we know that ND array is a kind of a new type here. And possibly D type, the data type of the observations inside it. These are all floating point numbers. And here, more than the floating point number, here we are talking about for the greater than, sorry, the false true. So false true is a Boolean. Whereas if you talk about these numbers, they will become a floating point number. So possibly another example. So we are taking random integers between 1 to 6, 1 to 10, 6 values, and we are reshaping them as 2 by 3, 2 rows, 3 columns. Similarly, array 2. And I want to say where array 1 is great. So here compatible. Both are of compatible length. So when they are of compatible length, it is an element by element comparison. So here the question is greater than or equal to. 6 is greater than or equal to 6, true. 4 is greater than or equal to 5, false. 8 is greater than or equal to 9, false. So it is how the calculation is typically being done. And one more function that you can think of, sum, mean, max, min, argmax and argmin. So argmax is something, possibly now you can see the location where the maximum has occurred. So argmax and argmin, they are talking about location. Here the index is purely based on the number here in NumPy, because you don't have a heading for a row or column. The good thing that pandas offers over NumPy is actually you can reference the rows and columns with names. You can put headings to the columns. Whereas in NumPy, we are not having any such kind. We are referring everything by numbers only. Right? So all these functions you can see. Possibly I have created these 6 temperatures. Right? These are the 6 temperatures that I have created. So possibly I can talk about max, temperatures.min, temperatures.mean, temperatures.argmax. So basically what should come here, you see, temperature.max. So the max should come 2.49. Temperature.min should come minus 1.43. Mean, possibly you can calculate. Argmax should come with this. Argmin should come out with the location this. So just let us see. So you see here, the max is 2.49, the min is minus 1.43, the mean is 0.10, the argmax is 4. This one is the max, 0, 1, 2, 3, 4. So the argmax is 4, argmin is 3. So this is what are some of the basic functions of NumPy. We will also be doing some of the advanced functions, but because we are done with this, I would save this and I would like to take some questions here. If one is 2 by 3 and the other is 3 by 3. It will throw an error. So just try it out. Right? Possibly we'll take one more column. So all your logics you can quickly plan around. You see, this is the one. Because they are not of the same element size. So only when there is a compatibility, they cannot. So this is the concept of broadcasting. Broadcasting is one array, the size of one array should be the subset of the other array. Possibly what I can try to say is, yeah, so only if it is a subset of the other. Basically, if it is a single element, then it can be broadcasted, but otherwise it cannot be broadcasted. So it will throw an error. Can you show an example of changing the range of uniform function with the help of designated array and rand? So it's as good as if you want the value. So basically, if you see here, okay, we'll do that. Uniform distribution. Yeah. So now I want. Okay, I'll create a question. So in the shape 2 by 3, I I say values between 3 and 5. Is this what was your question? Right. So I'll take np.random.rand. So I'll take 2 comma 3, which will actually make it as a 2 by 3 matrix. Now I know I want the values between 3 and 5. So I'll simply say 3 plus 2 times this. Right. So which is nothing but the interpolation that you typically do. So I say 3 plus 2 times this. Oh, this is a rand n, sorry. I'll have to take it as rand. So you see 3.81, 4.64, 3.54, 3.63, 4.43 and 4.81. Is that fine? Okay. Can we put anything inside the bracket of min and max? Okay, for that you better look on the help function. Max. So it does not take any kind of an input here. So it is not taking any input. So it directly gives the max of the array itself. So you can very well look at the function. So if you so basically I mean if it is so generally you will have the help that is available. So or the better way is okay. NumPy API library. This is one more way. NumPy reference. So this is for maximum. So you could clearly see return the maximum along the given axis. So you could see these are the various functions that are there, right? So you can very well refer to each of these functions. So if I'm talking about max, okay, yeah, this is the documentation. So you can very well specify axis. Okay, now we will use this. So you can look at this, but for time being, I'll take this one. Okay. So I'll use this one. Probably we will look at the random numbers that we have generated, rand int or something. Okay, here we have generated some random numbers, right? So I'll simply say temperatures dot max axis equal to 1. So when I say axis equal to 1, so you will see only column based highest. So you could see, sorry, row based. So you could see here, so in this row, 9.94 is the highest. And in this one, 2.49 is the highest. But if you are taking it as axis equal to 0, you could typically see in this particular column, 0.94 is the highest. So in this particular column, 2.49 is the highest. So here it is minus 0.43. So generally, if you want to get more details about the function, You go to this API reference for any library. You can go to their API reference and you will get lot more better information for each of the functions that you are looking at. So that way you can even improvise on your overall. Now, what are each of these things? Possibly you can look at this for the full documentation. Okay. Now we got access, none or integer or tuple of integers. Then possibly you are talking about out, alternative output array in which to place the result. So sometimes what happens is you look at it here and you can also see if they have given some kind of examples at the bottom. Generally they give some kind of examples to get more clarity. I think this is the way you keep learning. But most of the times what happens is we learn on the kind of a job. So we take up the data, we work with the data, and wherever we get stuck, you do a Googling of it. So sometimes what happens is very basic learnings, generally they get slightly stuck, right? We will be able to solve the bigger problems because at any point in time, you can do a simple Googling and you can get the necessary solution as well. Okay, so I think we are done with this part. Then I have a little bit of more NumPy in the next one also. So here, yeah, now we are going to do a little bit of more NumPy. As I told you, I may have to stop now. At least once we do this, I'll be stopping a little bit in ahead advance today. We'll try to cover it up somewhere else. So NumPy, I'm going a little bit more. Right now, we will be looking at indexing and selection. So just like the way we have done in case of regular Python, we'll be doing the same in NumPy as well. So look at this example. If I'm talking for a one-dimensional array, let's say I have taken a values from 0 to 9. If I want the values from 0 to 9, I will say np.arange of 10. I print the array. Right? Print array equal to this values. So if I want the element at the index 5, means I should very well say element array 5. So because we are talking of 0, 1, 2, 3, 4, 5. That is the index. Indexing is starting from 0. And if I want in a range, I can very well specify starting, stopping, increment. The stopping will not be included. So that is something that you have to practice, whether you do it in the base Python or you do it in NumPy, it does not matter, but you should be able to slice. Slice is something that you would be using not only in NumPy. When you go into pandas also, we will be doing the same thing. So basically, it should be better that you get comfort with it. The slicing, right? The subsetting, you should be able to get more and more comfort with the various functions. Then similarly, you look at it here. This is a two-dimensional array. So we have list of lists. And list of lists I have converted into an array by doing an np.array. So this notation you should be very clear of. I have a list. I'm converting that list into an array. I'm going to take for some more time. Okay. Yeah. So I'm going to have a list of lists. I convert it into array. Now let's try to access something. So the accessing of a list, be clear. Possibly this is one important dimension that you have to talk of. If I'm printing the array, then it would print as a 3x3 array, right? Now, location wise, you see rows are named 0, 1, 2, columns are named 0, 1, 2. So be clear on that. Now, possibly, let me not so now, can someone tell me what will be printed when I say array 1? So multiple answers. So we have to understand that 0 is the indexing, right? 0 is the indexing. Okay, so you can see 4, 5, 6. Okay, let me just close this. So 4, 5, 6 is what will be printed, not 1, 2, 3. Ritika, I think possibly, yeah, we should get used to it. The notation always starts from 0, right? So when you are simply saying a number inside it, only a single dimensional input, then it will give me only 1, 2, 3, 4, 5, 6. So it will give me 4, 5, 6 because this is the 0th row, this is the first row, this is the second row, right? Then print array 2, 2. So what would be the value that would be printed? Second row, second column, 9. Right. 9 is not 8. Someone is saying 5. No. Right. 9 is the one that is going to be printed because the array is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Second row here, 2 is not starting from 1. 0, 1, 2. Indexing is always from 0. 0, 1, 2, 0, 1, 2. So actually it's the third row, third column, which is 9. The same logic, if you are putting it like this, it's also the same. 0th row, 0th row, second column. Again, 0th row, second column. Second column is 3. Actually, it's a third. Right? So just practice it. So take some dummy numbers. Continue the practice. So because that's very, very important. As we move along, we will be seeing that. Possibly taking especially the 0th location, right? Or possibly, so otherwise what happens is you end up missing one value or you end up adding another value which is not required because you started from 1 rather than 0 and so on, right? Now, the next thing is, of course, the same thing that we are talking of, indexing and selection. So here also we are talking about slicing. Slicing is also the same. You can start, end, and a step. So which is, you have already used that in Python, right? So anything that we want to do as slicing, you can very well put this kind of a mechanism, starting, stopping, and ending and stopping. So if you have a range from 0 to 9 again, one-dimensional array, so you can very well say, so now you tell me, if I'm saying an array of a range of 10, and I want to take 0th value to the third value. So what are the numbers that should be printed? In an right, now you are right. Divya, I think you are on track. So you will start at 0, you will go up to 3, but you will not include 3. So it should be 0, 1, 2. Now, this one you just focus. I am going from 1 to end. In end, I am not giving anything, which means I'll go till the last in steps of 3. 1, 4, 7. Right? I'll go in steps of 3. So it is 1, 4, 7. Now similarly we can do. So here it means like you go till the end. But you start from 1, don't start from 0. Now again, if you see, this is a 2-dimensional array. In a 2-dimensional array, this is one more way. Possibly you are saying, I want, so you see array 1:3, comma 1:4. So 0, 1, 2, 3, 4. So basically that is what you have to say. Rows are 1:3. Columns are 1:4. So look at this. Rows are 1:3. Right? Columns are 1:4. So first row to third row. So you don't, so here the 3 will not be considered. So which means this is the 0th row, this is the first row, this is the second row. So first row and second row will be selected. But columns are 1 to 4. This is the 0th column. This is the first column. This is the second column. This is the third column. 4 will not be included. So basically it would be 7, 8, 9, 12, 13, 14. So that is the kind of a practice that you really need to do, because subsetting, slicing, they are very, very important requirements as such. All right. Then, okay, there was a question. If I need only the second column instead of the second row. So you can actually do it through this slicing mechanism, right? You can actually specify all your rows. Oh, sorry. So here, don't specify anything in the rows. Specify only the column. Don't specify, take all the rows and you specify only the column. Let's say 1:2. Only the second column will be printed. You specify all the rows and you specify only the columns. So 1:2 means it will start with the first column and it will not take the second column. Is that fine? Digij. Is it fine, Digij? Okay. So then one more important function. I think I am having only a couple of more before we move to pandas. So I'll finish the NumPy today and then possibly I'll stop. Okay. Then we are talking about the filters. So filters, actually, when you do pandas, we will do a lot of mechanisms of filters. Pandas is something that you will have to focus a lot more on compared to NumPy. Right? NumPy is helpful, but definitely pandas is something that you would be using quite heavily. So many features of pandas. So possibly 1 or 2 sessions I might spend on pandas also, because that will save your time when we are discussing on data science to a large extent. So let's take a simple array like this. I can very well create a filter. Filter means I will actually remove some of the rows or some of the observation and create a kind of a new matrix, new array. So let's say I want to create a simple rule. So array values less than 5. That's the kind of a filter that I am creating. So which means because it's a less than, greater than kind of symbols, it would be simply coming out as a Boolean, true or false kind of values. So you can very well print if you are printing this filter. So for all these 5 values, it will come out as false, less than 5, right? So basically all these 4 will come out as true and all these 5 will come out as false, right? But now if you say this is now put this thing. So I have all the true falses. Now I can very well take a subset of this data where there are only truths. That is what is the filter trying to do, right? So you can very well say, so otherwise we'll do one more exercise. Okay, it can simply used in an indexing operation. So I take the arrays and I put a below filter, I'll get these values. So possibly we'll do one more. My question will be, in this particular array, tell me which of the ones are even numbers, right? You use this and you can write the code for me. You use this above 1 and you can help me in writing the code. I want even numbers to be printed in this array. Or possibly I will take, we'll make it, we'll practice random dot randint, right? We'll say 16 size equal to 4,4. First, let's print this array. Did we write it right or not? So it has printed, right? So now I want to identify which of them are even numbers. So I can very well put it like even filter. I mean, I'm just giving you step by step. Possibly you can write it in one single line also, but I want you to know how to copy the things and work it out, right? So possibly you simply write it, even filter equal to array %2 is equal to 0. Compare with the 0. So this is what you are calling as even filter. So possibly if you want for comfort, you just print your even filter also. Then you are putting it to the array. In the array, you are simply referring to the even filter, right? So now let us see. The initial array is this one. So it is say checking if so this is true, this is false, true, false, because so each one, if it is even, it is coming out as even. Now finally the even numbers are being printed like this, right? So you can actually do such kind of small additional exercises also to get a hold, right? Possibly whatever I'm giving to you, you can typically change the values and you can quickly experiment. So for this, I'm not giving any specific assignment because you can pick up some of these things. But once we get into the data, I will give you 2 or 3 alternate data sets. So possibly whatever we discuss on the data, the same thing you will do on the alternate data sets back home, so that you will get some kind of a comfort. Then one more thing, we can use comparisons to replace the values in an array. So now possibly whichever are the even values, replace them with if something is an even value, replace it with an odd value, something like that. So in that case also, we can, once we get that true false, you can change all those values in one single step. Possibly, let's look at it like this. I have an NP array 5, 10, 15, 20. So I'm simply printing it. Now I want to say if this value is either 5 or 10. So I'll say this equal to 10 or this equal to 5. So which means this will come out as true, true, false, false. These are the values that are going to come. Now what is that I am saying? So whichever are the ones that are coming out to be true, make it as 50. So it's as good as here. In the same example, if I want to bring about it. So this is what I have got. So whichever are coming out as even filter. So the next thing that I'll say, possibly I'll print this as even filter. And whichever is coming out as array of even filter, I will put some other value to it, right? I'll say 25. They're all equal to, each one is a 25. So now if I say print array, you see wherever the even numbers are there, they are replaced with 20. So what happens is, these are all initial small building blocks. As you move into bigger problems, you will use the same constructs, but instead of 25, you will write a big business rule and you will say update the values with that business. So it might be dynamic there. So we will move towards that dynamism slowly. Okay, so just as a quick examples, can someone give me before we wind up for today? Can you look at the number 5 in the array? So what do I say here? I need to extract the number 5. What is the code that I need to write? No. I mean, basically the location. Yeah. Nabeen Sen has given. So it's more from a perspective of indexing and slicing. Yeah, 1, 1. So add 1, 1. Or you can say 1, 1 in the bracket as well. Okay, now can you print the first 2 rows of the array? R. And you have to print the first 3 columns only. R. Okay. Different people have different ways of writing. We'll test it out. It's not working. You just try it out. Now this is the one I will take. So it is printing. Now first 3 columns. So just take this. And you will have to print first 2 rows. Take this. Okay, so you can try, possibly there could be multiple ways of doing it. So just a quick practice is what is required, right? So just get into it, and I think I'll share this sheet as well. So in the next class, we will be looking into pandas. Possibly, I have to go today. There's a power problem and so many other issues right now. So I'll be leaving right now. Possibly I'll early stop. But we will try to cover it somewhere. If required, we'll take some additional sessions also by looking at the comfort of everyone.